Greetings, friends, fellow Earthlings, and explorers far and wide. Welcome to Ask an Astrobiologist, the show that celebrates the science and the scientists involved in our quest to understand the nature of life. As always, I'm your host, Dr. Graham Lau, known online as the Cosmobiologist, and we are brought to you by the NASA Astrobiology Program and SaganNet.org. As always, we like to start our shows with a big shout out to those people who are interacting with our poll questions we ask about our guests and who come live in the chat to ask cool questions. We had a couple of cool comments on our poll for this show, and so we wanted to share Johnny Time and Mohit Sawania, who both had really awesome comments on our poll that I'll share a little bit later in the show related to pigmentation of exoplanets and our guests for this month. But thank you, Johnny. Thank you, Mohit. And thank you, everyone out there who watches Ask an Astrobiologist, who reaches out to me, who reaches out to our guests, just to be involved in the conversation about our place in the universe. Now, this month's episode is going to be pretty groovy for a lot of reasons. It's going to be a very colorful and epic episode. Joining me today is Dr. Lígia Coelho. Lígia is a current 51 Pegasi B Postdoctoral Fellow at Cornell University, originally from Portugal, where she earned her BS in biology and MS in microbiology and a PhD in bioengineering and astrobiology. Lígia originally focused in realms of biology and biomedicine, including things like cancer research and infections diagnoses, and has now taken her work in microbiology to extreme field environments where she explores how the colors of microbes in these unique places can help us to look for life in other places on Earth, in our solar system, and way beyond. We're so excited to have her join us for the show, so please join me in welcoming Lígia Coelho to the show. Lígia, welcome.
Thank you. Thank you so much for having me.
I was so glad to have you on the show. You and I had a chance to chat last year at AbSciCon, and I was like, oh, I'd love to have her on the show. And then you were interviewed by Aubrey Zirkle for SaganNet for one of our Astrobiology Revealed articles. And I was like, oh, man, I have to have her on the show. So I'm so glad you get to join us now. I love to start off with all of our guests just sharing kind of their journey, what I like to call their science origin story, to play on the superhero thing a little bit. You originally worked in this realm of microbiology and biomedical research, and then have transitioned into this mixture of kind of astrobiology-related microbiology and planetary science. I'd love to know what your origin story was that got you interested in science, interested in astrobiology, and doing the work that you do now.
Yeah, well, as many of my fellow astrobiologists, the passion for space grew as I was growing up as well. I was always very passionate about the universe and all those questions. I remember, and that kind of freaked out my mom a bit. I remember being very small, like 4 or 5, and asking my mom, why is there anything out there at all? Why are we here at all? Things like that. And well, I'm in Portugal right now, and I'm from Portugal, and it's still a very Catholic country. So the answers from my mom were usually very religious-driven. But that didn't satisfy me. It's not like I didn't believe it. I was like, sure, okay, God, fine. But still, I want to understand why we have things here and there's things there, and how does that work? But I got to say also that in Portugal back then, and while I was studying, astrobiology wasn't a thing that a Portuguese would aspire to study. So I went into other paths. I was very fascinated by microbiology as well when I entered university. Basically, anything that was outside of the scope of my eye, I liked. I liked astronomy, very big dimensions, very far away things, and I liked microbiology, very little, very small. And both worlds made me very curious. And while I was studying, I understood there was actually a connection and also by works of Carl Sagan and other works that I was reading, Lynn Margulis, all of that started making me very curious while I was studying microbiology. And I started thinking this connects with space somehow. It has to be a connection. But one of the things that were very big at the time for us to study in Portugal was biomedicine. And that was what was available to me. And I'm a firm believer that if you go to the lab and you start learning techniques, they are translatable to the things you'd like somehow one day to study. So it's not bad to start with other topics for you to explore. So I did plant physiology, I did cancer biology. And then I got this amazing opportunity from the MIT Portugal program. The MIT Portugal program is a consortia that was created between the Portuguese Science Foundation by the government and MIT in Massachusetts, as Massachusetts Institute for Technology, so in the US. And that connection was made because Portugal was creating a lot of good science that was not patentable because they were publishing first and they didn't know how to tech transfer their science. While in the MIT, they were experts at it. So they wanted to have this batch of scientists, new scientists in Portugal that would go to the MIT, learn the ways of science tech transfer, come back to Portugal and apply it so that universities would become a bit more autonomous in the way they would fund themselves with their own science. And that was a very competitive call. And I was competitive at the time for that call because I had already kind of a startup during my master's for diagnosis techniques for women with urinary tract infections. It was a one-time experience. It didn't go very well, but it taught me a lot. And they thought that was an interesting profile because I kind of have done something already during my master's. And they gave me the scholarship. And they were thinking that I was going to do this maybe startup for cancer research, maybe because of my profile. But the problem for them was that they put me in classrooms with all these kinds of entrepreneurs with very interesting ideas and very bold ways to do science and to think about things instead of the more academic type of professors. And one thing entrepreneurs love to do is give us advice, sometimes unsolicited, sometimes solicited anyway. And I was already not feeling very passionate about the cancer research part after the master's. I believe in the mission 100%. That's why I tried it. But I felt I was kind of taking the place of someone that was really passionate about it. The kinds of questions that made me think about things in my shower or during laundry or whatever were different, were not the cancer-related ones. And so I knew already something was not right. And the thought of spending 4 more years studying cancer kind of made me a bit depressive, if I am to say honestly. So I talked to some of these entrepreneurs, and one of them said, "Do you have a passion?" And I said, "Yes, I have a passion." And he said, "Okay, nobody ever again is going to give you 4 years of funding with no agenda for you to pick whatever you'd like." Because one of the things the MIT implemented in this consortia was that, okay, you want to learn our ways? Okay, one of the things we do to our students is they don't come bound to any project and they can explore and then pick their project. So Portugal kind of had to do the same thing. So I was bound for the cancer research, actually. I was not binded to it. They just kind of, I think, thought I was going to pick it. So this entrepreneur told me, nobody ever again is going to fund you for 4 years without any agenda. So if you want to change for something you're passionate, do it now. And I took the advice, I took the risk, and I changed completely to astrobiology. I created a committee, external people, internal people in Portugal that together allowed me to have all the different techniques that my astrobiology topic required. Astrobiology is extremely interdisciplinary. So I had polar scientists, chemists, biologists, astronomers, all together in my committee. And I was able to build this topic. And I think, and I cannot guarantee this, but I think I'm the first PhD thesis in that university that had the word extraterrestrial in the title. So it was really kind of a big risk because there was no support, no established support for the type of topic that I had, which made me, again, learn a lot. And having a lot of committee members also taught me I had a lot of people to please, let's just say. So he also taught me how chemists think, how astronomers think, how physicists think, how different that is from a biologist way of thinking. How these different people are satisfied differently with papers and analysis and data. So that's how I came to astrobiology. So basically, I went from a biolab that it was focused on cancer cells from a cancer tissue lab kind of thing, 100% petri dish biologist, into the environment. My first task of my PhD was going to the Arctic. So I have never seen snow at that point. I had never worked in the environment at that point. Everything looked dirty to me because in a tissue lab, cancer lab, everything has to be mega sterilized. There's no concept of a community of microbes. There's no concept of everything counts. In a medical lab, everything is poop unless it's what you want to study. So my mind completely had to change, and I didn't lose what I had. It was just I had to kind of compartmentalize and use what it was required for different things and tasks and questions. And then I started loving the astronomy so much. It was already a passion when I was a child, so I couldn't help it. And the part that kind of pushed me more into in my astrobiology thesis was the astronomy part with the exoplanets. So then I got a postdoc at Cornell. Throughout all this, I also had an amazing mentor, Lisa Kaltenegger. She's an astronomer, but somehow she was able to advise and mentor a biologist into becoming a bioastronomer or something like that. And then at Cornell, I was able to take all the classes needed, the astronomy part of my work. And that's the place where I continue to work, and very happily.
That's awesome. We have not had Lisa on the show yet. We should at some point. She's wonderful as well. But there's so much to unpack here. And I'd love to just start. I often share with young students, one of my key pieces of advice for those who are interested in astrobiology is that you have to think like a generalist and a specialist. Many of us have to come generally with some knowledge from astrophysics and biology and chemistry and geology and oceanographic and atmospheric science and philosophy and all these different realms. But we also all specialize in a few specific places. I've been fortunate myself to do Arctic research. There are others in astrobiology who get to go to polar environments in the Arctic and Antarctica to explore these environments, to test what we do in the laboratory and compare that to the field, and then use field observations to look elsewhere as well as in looking for life. And so I'd love to hear a bit about your experience, especially in going into the field. You mentioned it's, like this dirty kind of thing. It's a different environment than thinking about a biolab where everything has to be super clean. One reason I chose geology for my PhD in the long run is just to be outside. I love being outdoors, and I know a lot of folks who've done the same because they wanted to go do research in cool places. And for you to see snow for the first time, going to do your field work in a very remote Arctic environment, it must have been just staggering for you to have this experience. And so I'd love to hear more about your experience going into the field and applying microbiology as a field researcher.
You know how you can put all your knowledge and growth in a plot, and then you have those stagnant points, and then you have those points where you kind of go straight up. And it was one of those points where in a couple of days, I grew as a person and I learned so much as a scientist. And I was happy at every single moment. And then I learned that I love snow, which is kind of that, Frozen Olaf, the snowman that loves the sun in summer. I'm kind of the opposite. I'm the Mediterranean that loves the snow, even though I was not built for it. My biopigments are not built for it, but here I am. I loved every single second of it. I loved the landscape, the peace. I loved the wonder of everything I was looking at and being completely new and thinking, oh my God, how is there this amount of microbes in here? How am I actually seeing the algae in the ice? How is this possible? It was, I think, one of the best moments of my career and life as well. Yeah, but I completely agree with you. An astrobiologist is exactly that. He's a specialist with no fear of being generalist. And I think I would add a bit to that, if you allow me, and no fear to feel dumb. Because if you're talking with all these experts, and here I am, a biologist in an astronomy department, right? If you're afraid to make questions because you're going to sound dumb, it's not going to help you. And I'm comfortable with it. I'm comfortable with people thinking, here she is making these very basic questions. Because ultimately, if I get the answer, I know I can put it in this drawing that I'm making in my mind about the bigger picture of things, and that's okay. But then I'm also going to meet very kind people that are very eager to share their knowledge with me and ask questions about my work as well. And that's when beautiful beautiful joint work and collaborations come together. And astrobiology without collaboration does not exist. Field work without good collaborations does not exist. I actually have also a theory about field work. When we go to the lab and we start an experiment, the first thing we do is the question, science question, then the hypothesis. I think it's this, so then I'm going to do this and this and that. For fieldwork, I think it's different. I think we have a science question, and then the second question is, who do we know and where? Can I answer this in Greenland, or do I know someone in Svalbard, or do I actually have to go to Antarctica? Okay, maybe it has to be Antarctica. Then how does this change my first question? There needs to be some flexibility, also because in the lab we can repeat things as much as we want, in a way. And in the field, we have to adapt our questions to the conditions of the field. We cannot be too stuck up to a question and to an hypothesis. We have to take whatever the environment give us, and we have to see the data as they are. And we don't have to agree with it, and we don't have to create a lot of. We shouldn't create a lot of preconceptions and a lot of expectations. We just have to respect what it is and take what is there. And that is very different from a lab researcher, especially coming from the biomedicine world.
Yeah, absolutely. I love that you pointed out how collaboration is so important for us to go out and do these kinds of projects out in the field to learn more and work together. Astrobiology is very collaborative as a discipline. I'd like to just chat a little bit about your field experience. We were chatting before the show, and you had mentioned how you also learned how to ride a bike for the first time while you were at 79 degrees north in the Arctic at the age of 32. And I wonder if you can share that story for our audience, because I find it so cool and fun.
Yeah, so I'm the Mediterranean that likes to go to the ice without knowing how to swim or how to ride a bike or even drive. So I don't have, I would say, a lot of the skills people would agree are necessary to do field work. And I would agree with them as well. But I'm too curious to not go. But I also never thought, okay, driving the car, maybe because of the snowmobiles, that's fine. But there's always someone driving and you can always go on the back of someone. But then I would never think I actually needed to know how to ride a bike. Of all the skills I just presented to you that I don't know what to do, I never thought riding a bike would be the first one I had to learn to doing fieldwork. So I went to Svalbard last summer and I had everything prepared. It was actually the first fieldwork excursion that I had to do a lot of the logistics myself. I had support from my collaborators, of course, but it was the first time I was the PI of a project. So I was quite, stressed with it. And at the end, I arrived to Ny-Ålesund with all my bags. Everything was there, more or less, minus some cases that the airlines missed. But okay, I had the plan B, C, and D. I had everything accounted for. And I was like, right, now, where is this location? Where is this... I'm missing the word, sorry. In the Arctic, you have tundra and you have the elevations, which are...
You have some mountains, glaciers?
Glaciers.
Yeah.
Here is the polar scientist forgetting the word glacier.
That's totally fine.
Anywho, yes, and I was like, where's the glacier? Let's go. I'm so excited to see the glacier. And they were like, yeah, sure. So this one, we need to go by bike because there's no more ice, so there's no snowmobiles. So we have to actually either walk or ride a bike. But for this one specifically, we would rather ride a bike because there's actually a way already created by the station for us to be able to do that. And the station has bikes. And I was like, no. I don't know how to ride a bike. And everybody was so surprised that I didn't know how to ride a bike. I guess that's fair. And so I said, I'm not above having to learn how to ride a bike at 79 degrees north today to make sure that in a couple of days we can reach this glacier with minimum, reducing our effort by not walking and carrying while walking all this material. So let's go. Where's the bike? And then I see these very big bikes. They're not tailored for my size at all. And I was terrified. But we were fortunately in front of, I was in the NERC station, the British station, but fortunately we were in front of the Dutch station. And as everybody knows, the Dutch are world leaders in bike riding. It's like a Dutch baby is born already biking in a way. And they had all these Dutch bikes that are kind of more adjustable and easier to learn. And they also had Dutch people inside that were seeing me learning in the outside with my colleagues, Laura and Marshall. They were there teaching me for 2 hours, but then this Dutch person is inside looking through the window, this Dutch ginormous man looking through the window, seeing me, becoming frustrated at me at every minute passing. And then he just opens the door, comes outside and say, "Get on the bike." And I said, "No, I'm not getting on the bike with you. I don't trust you. I know you're going to let me go. I'm not ready yet." Because at this point, my colleagues that were teaching me, they were incredibly soft and supportive and, not pushing me too much, but he was not having it. He was watching me for 2 hours and he's like, "This is not how you do it." So I went on the bike, terrified, and he just started pushing me with all his strength. And 5 minutes later, I looked back and he's no longer there and I'm riding the bike. So it was such a fantastic moment to overcome that fear and overcome that skill, right? And dominate that skill in a way in such a short time while I'm already so old to learn in a way, I think. Because the problem with the 32 versus a 5-year-old is that I know that when you fall, it hurts. While a child, they don't know that. So that's why it's so easy for them. And I fell a lot of times because learning requires falling and learning how to stop the bike. And then I was falling a lot because, again, the bikes were too big for someone my size. So if you cannot put your feet on the ground and you don't know how to stop the bike and you're not experienced, you're going to fall and going against things. But yeah, so it was an amazing experience. And someone told me, "You might have a Guinness record," because I don't think anybody had learned how to ride a bike that far north. And I'm like, okay, I don't know how that works, but perhaps I do.
Nice. That's awesome. I mean, so it's incredible. There are challenges to field work, and sometimes it includes learning incredible new skills. You did mention how the bike wasn't quite fit for you. I do want to shift gears a little bit. We had spoken before the show as well about how traditionally and historically some kinds of field work and some kinds of application of putting the human body into extreme environments has not been fit for all sizes of people. It's been targeted primarily towards men, and specifically from very specific regions of the planet. We had Penny Boston on the show previously. I remember Penny speaking to me many times in the past about how when she first got involved in speleology and cave research, that all of the gear was meant for men, and there wasn't gear meant for women. Some folks watching might recall a few years back when on the International Space Station there was supposed to be a spacewalk involving 2 female astronauts, and they ended up not being able to do it because NASA didn't have the appropriate spacesuits available for 2 women to have a spacewalk at the same time. And so I'd love to talk about your own work in this realm of accessibility for getting all people involved in things like fieldwork and space exploration. Specifically, you're part of a group who come together to create AstroCup, a menstrual cup for women who menstruate when they're in space. And so I'd love to hear kind of what was the vision for this, what brought it together, and what inspires you to want to work on something like AstroCup and be involved in helping to change things to make space exploration and field exploration more accessible.
Yeah, I mean, it is true that I do field work, but as the person in field work being kind of the victim of not having the right equipment, like many women do, I never made this connection between lack of devices, proper devices for women's sizes in space, and connecting that with fieldwork initially. So it was not my experience actually that led me to this problem. It was another experience that I had, but in a conference in the space agency. I'm not going to name the space agency, but I was in a conference learning about radiation, and there was someone there that took care of the health of of astronauts in general and did a lot of studies related with that. They were not the chief medical staff, but they were connected with with the research that is done to improve the well-being of astronauts in space. And they were talking about what is going to be the best profile for the first astronaut in Mars. And all the rhetoric was kind of against not being a woman. Against being a woman, not they were making it all sound that the perfect person would be a man in their 60s and all that, and it was very based on radiation and the age and all that kind of made sense. But then the woman part was not quite registering with me, and I was like, why? I mean, a man and a woman, they are very, they are very similar in their susceptibility to radiation, right? They had all these anecdotal data about how women tissues were more, in certain places, were more susceptible to cancer than men's. The data was not very sound because it was all based in Hiroshima and Nagasaki events. So very old data, very biased data as well, as we are thinking about the amount of women and men that were in Hiroshima and Nagasaki during those times, for instance. But that, I let that one go because I was like, maybe the data, maybe they're right. I hadn't read before a lot of the data about that data, so I was okay. And then they said, and then there's the problem of menstruation, because putting pads and tampons in cargo is so expensive. This was way before SpaceX was this big, and Blue Origin and SpaceX had already diminished this cargo freight price a lot since then. This was 2017 or 18. So back then it was $100,000 per 1 kilogram or something like that. So it was really expensive to send cargo. And they were saying, but 1 kilogram of tampons and pads, and they have to be sent every time. And if they are in Mars and the moon, is so complicated in the colony, because we have to keep sending these, and then disposable is so problematic. And I was thinking about this, and I was like, what about menstrual cups and menstrual pants? They are not disposable per se. If you do a bit of research, for sure you'll find a way to make them reusable in space. And they said, menstrual what? And this again is 2017. Menstrual cups are being used since 2001, and menstrual pants, at the time there were already a few brands that were very, very wildly used. And by that answer, I understood exactly why these menstrual devices weren't being tested. It's because the conversation never started. And then thinking about my experience in the field, I know exactly also why. Because the people that are being the ones not having what they need are also the first ones not wanting to speak about it, because we are already kind of looked like the weak ones that everybody's seeing, trying to judge if we are fit for work or not in the field. And the least fussy we look, the best for us. That's usually the conditioned way of thinking we all are in the field. Unfortunately, still today a bit like that. We never want to look like the ones that are too behind in the field excursion. We feel judged if we are looking like we are afraid of something. We feel like people are kind of judging us, actually, which is surprising to me. I'm a scientist. I'm not Bear Grylls. I'm doing this because I'm curious about the samples. I'm not doing this because I want to look like a superhero. Anyway, with this said, I know I in my mind, it made a lot of sense that this was not a scientific problem. This was definitely not a technology problem. I mean, we are already developing robots to do surgery remotely with personalized medicine and AI in Mars. The robot arms already exist. And somehow we already have women in the ISS. We have nobody in Mars, but we have women in the ISS. And still, there's no solutions for them to have options to menstruate. They currently are not forced not to menstruate, but the only option given is the 100 tampons, or they have the hormones injected in them. Again, I'm not saying the astronauts might not be happy with the injection to suppress the menstruation. Maybe they all want that. What I can guarantee is that that's not going to be the preferred option of every astronaut that is coming to start working, especially for colonies in the moon and Mars, where they'll have to suppress their menstruation for 20 years or 30 years. And so I gathered and rallied this group of aerospace engineers in Portugal that I knew. They all were always looking for something to put inside rockets because they designed the rockets and they designed the payloads. And together with another colleague that is also an astrobiologist, Catarina Miranda, and now she's our SciComm as well because she then developed a lot of skills in that. We decided to put the first menstrual cups in a rocket to send it in a suborbital flight and show everyone that we actually don't need rocket science to have menstruation because the menstrual cups obviously survived everything. We just need to repurpose the amazing work being done for women on Earth, kind of behind in time, but we are already getting some options, right? Repurpose it for space conditions and give women astronauts options. I'm not again saying the menstrual cup will be their preferred option, but what I can guarantee is that on everybody looking at me right now in this show, and women that are menstruating or that menstruate, we don't all use the same thing. I can guarantee this right now. I'm not going to say what I use, but I don't need to. I know they are thinking the same. I don't use what she uses maybe. And this is because we like options. We don't like being told what to use in these kind of things. So it is imperative that these options are given if we want a colony anywhere.
Yeah, I love that so much. And it's very thoughtful, this idea of having options for female explorers in the future who are menstruating, especially like for Moon and Mars exploration. Some astronauts will be spending not just a few months or a couple of years, but many years in these new environments. And we're going to have to live as people in these new environments. So I'm so glad you're doing that work. I hope our audience will check out the AstroCup team and learn more about all of them and their amazing work. For timing's sake, I do want to shift. Yeah, go ahead.
Can I just ask you a small question? That is actually true. And the contract for an astronaut in going for the colony in Mars for a man is not going to be the same contract for a woman, because if they continue to suppress the menstruation, the contract is, do you want to have your normal menstrual cycle ever again or not? Do you want to have a fertility eventually, or do you want to have kids eventually or not? And that is the question being asked to women, but not to men while going for a colony. And that, obviously, it's not fair.
Yeah. I agree entirely. There should be equity in how we approach these things, but also while addressing our differences and similarities together. And so that is important for space exploration for all of us, and for field exploration, and for just living life in general. I think we could all do a much better job. So for timing's sake, I do want to just shift gears a little bit before I go over to our next segment and then our audience Q&A. Just to speak a little bit about your current research and some of the work you've been doing of late in your postdoctoral program. We put a poll out on YouTube before the show asking people of different colored planets like yellow or orange or blue or purple planets, what kind of coloration of a world we might detect out there based on your current research. And roughly 50% said the answer was purple and enjoyed it. We also had some really great responses in the comments. But I'd love to hear from you kind of what you're doing in this realm of microbiology, looking at pigmentation and why there could be purple planets out there.
And that's my day job, not the menstrual cup part. That's true. So we should definitely talk about that. So my work is on trying to constrain what sort of life we could detect possibly in the surface of an exoplanet. And in my point of view, that is better achieved if we look for biopigments. Biopigments is a biomolecule that all living things can produce. We produce melanin, for instance. And the reason why we produce it is to fight the stresses of our environment. So our melanin is for UV, to fight the photooxidation effects of UV in our body, and also cancer or any other things that can be created by extreme radiation. But in other organisms, it can be for them to have protection against desiccation, protection against lack of resources. Think of flamingos. The pinkest flamingo is the one that is luckier in the reproduction dance, right? So biopigments are here to help us survive. And also, they help us survive a lot of the things that I call the weather forecast in space, which is radiation, lack of resources, dryness, changes in temperature, and all this. They also have an amazing thing about them is that they are incredibly detectable with spectroscopy, which again, it's what we are always going to have and only going to have in these telescopes looking at exoplanets. For the icy moons and for solar system targets, we can invent these beautiful toys and machines that are going to be much more sensitive to detection of molecules. But for exoplanets, we are always going to be very far away, so we can only use spectroscopy. So whatever biology we are trying to find on an exoplanet through Earth's work, we're always going to have to translate all this amazing biology into just one language, which is spectroscopy. And biopigments do that extremely well. So what I've been doing, and I've been going to the field, getting all these colors of surfaces, and I've been bringing them to the lab and growing them and measuring their reflectance so that one day observers are going to have all the references needed to not miss any sign of a biopigment on the surface. I'm also creating these models that make it more easy for adapting to every type of telescope. So the idea is to not do as much of follow the water, but instead follow the color for the surface on an exoplanet with direct imaging. So I'm obviously talking about future telescopes, not James Webb, but future telescopes like the ELT, Extremely Large Telescope, which is an European effort that is going to have the first flight in 4 years. And I'm talking about the Habitable Worlds Observatory from NASA that is in the concept phase right now. And I'm being part of their meetings for surface biosignatures.
Very cool. I'm going to just share a couple of questions from our audience that came in fairly early. Isitu Star had wanted to know how we can determine between like biological and abiotic reflectance spectra or absorption spectra when looking at exoplanets with these future telescopes, and maybe like the realm of possible pigmentation that we could be looking for from living things.
So when we look at the spectra of these biopigments, we see a lot of specific features, ups and downs, step functions. One of the most known one is the vegetation red edge, which is this peak in 680 nanometers that is connected to chlorophyll A. And we can observe that from outside, from space, looking at our own planet because we are so covered in it. And this actually connects to the second question that was made about what type of pigments can we look for, and I forgot to answer that. So on another planet, we shouldn't just focus on the green. We should focus on all these pigments that can be connected to different environments. So if you think about an environment with a lot of red energy, so heat, infrared light instead of visible light like our planet, we should look for purple bacteria or purple biopigments. Or bacterial chlorophylls that are connected with these purple bacteria, which are actually biopigments that are peaking in the infrared instead of the visible, like the vegetation red edge that I just explained. So instead of 680 nanometers, they will have this beautiful feature at 1,000 nanometers, in the infrared. And then that changes completely the models with the atmospheres overlapped and everything. So people are actually using the wrong model for life at the surface for these planets around stars that give more of this red energy. And by the way, these are the most abundant stars in our galaxy. So in terms of numbers and detection capacity, those are the best targets. And we were using green instead of purple. And then if you take this as an example, just think about all the colors that we are missing in this catalog of planets and potential planets. We already did the catalog of life in ice, showing 80 different colors that are possible in icy worlds and icy exoplanets. But also we are showing these purple planets that could be around them stars, but also early Earths. Earth before oxygenic photosynthesis, the green photosynthesis, had an oxygenic photosynthesis, which is this purple photosynthesis. So maybe Earth was purple before cyanobacteria took over. So maybe an alien looking at early Earth should have had the purple signature in their model to detect life on Earth, not the green one. So this is what we have to think about. Maybe we shouldn't have only the green one either when we're looking at their early Earth. And then you can think of black planets for radiation with melanin. You can think about all things. There's over 1,000 different biopigments. We cannot and should not have them all measured. What we should is have biologists on the table narrowing down the options, and telling you how to make more biologically informed exoplanet surface models.
I love that. And I love the idea, like, not only of early purple Earth long ago, but that our cosmos out there might just be filled with planets of many different colorations due to the sheer presence of life. I do have to jump into our Faster Than Light segment here in just a moment. But as we always say, the show is about the science and the scientists involved in our quest to understand the nature of life. And we always love to just point out some of the interests that our guests have. You shared with me before, well, we did the show, that you practice yoga every morning, that you love birds and plants, and that you love reading. You were an orchestral singer. And so you have a lot of hobbies and things that have driven you in your life and your own passions, besides just the science and all of the other research that you've done and your interest in things like AstroCup. So I guess one fun question would be, what was it like to be an orchestral singer?
I loved it. I think music, it's just one of the most pure pleasures we can have from nature and from civilization, maybe. But there's music outside of humans, to be honest. Maybe we shouldn't claim that. And it's one of my biggest passions. I don't think I'm alone in this. I know a lot of astrobiologists, astronomers, biologists, geologists, you name it, scientists that are connected to music still today and give concerts and everything. And I think one of the best things was that sometimes science can be kind of an isolate work. So if you're writing your PhD thesis, you're in your bedroom. I wrote it all in this bedroom, actually, my baby girl's bedroom, before I moved out. And then making sure that I would have to get out of the house every Friday to do practice and actually connect with other human beings that have different works, different jobs, different lives, but we were all connected together, doing the same, looking at the conductor and understanding the same language and speaking the same language. It was amazing for my mental health and for me as a human to always be cheerful and happy and connected to the arts.
Yeah, absolutely. I mean, I play guitar. I've been playing since I was 5 years old. I think most astrobiologists have some passion in art and creativity, including music. So for timing's sake, I do have to jump to our Faster Than Light segment. This is the segment where we ask the same questions of all of our guests who've joined us on Ask an Astrobiologist, just to gauge this realm of understanding of what it means to be human, asking these big questions. And so my first question for you is, what is your favorite thing that life on Earth does?
I think it's a really close call between photosynthesis and music. I don't think I can pick. I mean, without photosynthesis, we couldn't do music. So if we go by that, I would pick photosynthesis. But I heard someone once say, and I'm not very religious or believer of or many other things, but I heard someone say, music is proof that God exists. And although I don't believe in God per se, I would say that I completely understand what that person was saying. It feels like a miracle that we are able to do such harmonious things with sound and with air, actually.
Yeah, absolutely. There's this beautiful, like, awe and wonder experience that happens when we share music and sound and art together. It really is beautiful and moving. Okay, my next question. If you could communicate with any non-human organism on Earth, what would it be and what would you want to talk about?
I would definitely go to those purple sulfur bacteria and ask, look, was Earth purple or not? Just let me know what was the color of early Earth. That would be very helpful.
That's a good one. I like that. It'd be really cool for your research too, like just to talk to the bacteria and ask them how things have been.
Yeah.
I love that. And so for myself, I'm a huge sci-fi nerd. I play video games. I love watching movies, especially like sci-fi horror films is my thing. I'm curious, from your standpoint, what stories have inspired you to want to learn more about life in the universe?
You know, one funny thing about space for me is that reality is so exciting that I never really felt the need to go into the sci-fi part, especially as a kid. Now I do enjoy, I have right here, Andy Ver, Project Hail Mary right here. And I do enjoy now a bit more of sci-fi. I just watched Star Wars for the first time a few months ago. Do not judge me. Do not judge me. I did enjoy it. It took me a while to get there, but I did enjoy it. But this to say that as a kid, I never felt attracted to sci-fi, actually. I was attracted to the real deal of things that were already discovered, the real science books, let's say. And that already, took me everywhere in my imagination. I can tell you that I know that I started liking space because my dad would tell me stories about the moon, everything. Then I started wanting to go to the moon. My mom started buying me books to dissuade me from going to the moon because Laika died. She said, do not go like the dog. And then I was like, what? A dog went to space? Tell me more. So all these things really nurtured my curiosity. And they were all just real facts or things we thought were facts, but are no longer holding, actually. And then as, time grew and I grew up, I started touching a bit on the sci-fi, but that was not the thing that took me to space.
I mean, with no judgment, I'm glad you finally watched Star Wars because like Star Wars is absolutely incredible. It inspired me as a young child, but I was kind of the same too. I love documentaries. There was one that came on a television channel in the U.S. called TLC. I'm not sure if it was international or not back in the 90s.
It was.
It was called Solar Empire, and it was hosted by Michael Dorn, who was an actor in Star Trek. And I remember watching that as a young person, and I was like, oh my gosh, I'm so inspired to like go to Mars and go explore space. And so sometimes I wonder in my own career if I could restart it, if maybe I should have been a filmmaker or been more involved in creating documentaries. And so another question for you is, if you could go back and visit yourself at the start of your career, what advice would you give yourself?
Do not be afraid to stand up for yourself. I think a lot of young scientists are afraid to speak up, to defend themselves when injustice strikes or when people bully you, because we are afraid that might cost our career. If I speak up, it's going to cost my career. And I can tell you that what I feel more bad about when I look at the past is the times I didn't speak up. I regret them. And I don't think they will deter you from your career per se. Standing up for yourself gives you a lot of power actually over your career. And you don't have to be rude. You don't have to be violent. You just have to say, no, that's not true. That's not fair. And for me, that makes me the next day, the next year, the next 10 years actually look back and think, okay, I feel good about what happened because I did what I could do to prevent any sort of abuse against me. So I would say to my young self, don't be afraid to stand up for yourself, because eventually you will learn that's the only way actually to go in this career. And you're going to see that the world keeps spinning. There's no actually big problem. And you're going to regret not having started earlier to do so.
Yeah, absolutely. Yeah, we don't want to face the regret. We need to be active for ourselves. And I am hopeful that we can find some way to be more compassionate and empathetical in the future and create better systems where people do feel more able to speak up for themselves or to speak up for each other. It is very important. That excites me about our possible futures. But what is something that excites you about the future?
Well, I can tell you that one of the things that's been exciting me a lot lately is as I'm starting to teach my first lectures, the feeling that I might be in the room with the person that is going to find life somewhere. And the fact, or the group of people, it's not going to be a person, it's going to be a team, right? Let's destroy that hero, Nobel for 3 people concept. It's not like that, right? The fact that I may be actually inspiring or giving some important information to the person or the group of people that are going to look at data one day or through the lens of a telescope and find life, it's really exciting for me. Thinking that the next generation is actually maybe the one that is going to do it, and we are being part of giving them tools for that.
Yeah, absolutely. I love that so much. There's so much to hope for the future. And I feel that too when I speak to these young students from around the world who have so much passion and they want to change things. And even though I'm still hopeful that I can be involved in large collaborations that do really awesome things, it is really exciting just to think of what we're passing on to that next generation of explorers.
I do mainly theoretical work. So I know I'm never going to be the one looking through the telescope, right? And it might be actually someone in archival data that is going to find life. That's also possible. I'm not too attached to the idea it's going to be me or I'm going to be part of it. Or I would also love to be alive to see it. And maybe I will. Maybe I'm just going to be the one doing all the hard work in the lab or the hard work in the observation. So I know it's going to be someone younger than me at that point. And it's exciting to think we are also part of it in a way because we are giving them all the information we learned until now. And that's really, really inspiring to me.
Yeah, absolutely. I have one more question in our Faster Than Light segment, and it's the really fun one for most people. What is an unbelievable science fact that still blows your mind?
I have a lot of science facts that blew my mind. Actually, that's the main reason I keep doing what I do. One biology one is the fact that bacteria, microorganisms are actually quite selfish. When they are in the environment, they don't like to divide that much. And that is why we see a big difference between how much bacteria grows in a plate in our lab and how much bacteria actually is on the environment. And that is an important thing if you're trying to find life in the surface of an exoplanet, obviously. But if you just look at the biology of it, if you really learn how they actually prefer to exchange DNA more laterally with viruses, is an interesting thing how their behavior changes when they are out of the environment. Another amazing thing for me is the fact that we have a lot of hot Jupiters. So we think of Jupiter as this planet that is far away from the sun, and it's cold, and it's a gaseous cold planet. But in other solar systems, these Jupiters actually migrate towards closer to the star, and they become hot Jupiters. And their chemistry completely changes because of the temperature and the differences in temperature. And those are actually the ones we are more acquainted with because they are the easier to observe. We are not sure if they are more abundant than the other Jupiters. That's an open question still, but it blows my mind. And finally, I can just say another thing that blows my mind is also about exoplanets, and it's about microlensing. There's this technique to find exoplanets, which is finding an exoplanet you can't see around a star you can't see, because there's light coming a star you don't care that is being bent by this conjugation of star and exoplanet. You'll never be able to characterize the exoplanet, but you can detect they are there, and they are everything's completely invisible to you. So this is microlensing, and it really blows my mind. The other day, I was I was learning about a new planet and a new system that were detected through microlensing, and I went to my office. I sat down. A colleague just passed by, and I said, I'm going to change fields. I'm going to study microlensing now. And they said, you do remember that you started as a biologist and that you cannot actually see anything in these exoplanets. And I'm like, yeah, that's true. But I don't know. They're super, super, super fun to think about.
Yeah. Absolutely. So yes, to all of these things. I will say there's a very cool concept idea someone put out, a group put out some time back, of using our sun as a gravitational lens, of putting a bunch of spacecraft about a light year away from our sun and using it as a gravitational lens to image the surface of an exoplanet. And so who knows what the future is going to hold for these kinds of technologies and possibilities. Maybe even our knowledge of physics will change that will allow us to see exoplanet surfaces, and lensing could be part of that. I know it's so incredible. I am going to jump to our audience questions here with this little bit of time we have left, just to respect your time that we have here. I think, it's always fun seeing what the audience brings in for their own questions based on our guests' past experiences, current research, interest, and things like that. One of our audience members, Nabila Anis Binti Yahaya, wants to know, based on your past research or your past work in biomedicine and cancer research, what you think of advancements towards actually curing cancer. And I think I'll add on to that the relationship of understanding something like cancer growth in humans and other animals, and how that relates to our knowledge of astrobiology and life.
So cancer researchers definitely have a lot of tools they can translate into astrobiology, because if you're a cancer researcher, you're trying to detect life that is not supposed to be there, or that you don't understand the environment, and try to dissect that from the other life that is there around it, which are the healthy cells. So there's a lot of translational tools, and that's why I was able to shift, because I was detecting life, and now I'm detecting life. So it's kind of just different life. And on the advancement part, I'm already a bit out of the literature, because it's hard to follow all these journal clubs already in astrobiology, let alone if I add the biomedicine. But I do still have my group of friends originally from that field. And it's very connected with AI now. AI to see if the drugs are going to take an effect or not. If not, they can adjust the drugs or or actually decide not to put the patient through a very painful therapy regime, or they can use it for detection, use AI and personalized medicine techniques for diagnosis, or it's also a lot based on preventative medicine nowadays. But preventative medicine is not something all countries invest equally yet. And a lot of the preventative medicine is actually eating well, doing exercise, doing a lot of diagnosis tests, as time is passing, to make sure you catch things early. And so the path for cancer is, again, multidisciplinary. It's a multi-path. Cancer is not all the same disease. In every organ is a different disease. And it requires all these three fronts. And again, AI and machine learning are kind of revolutionizing everything. And the idea is that in 10, 15 years, we are not going to go to the hospital at all for a lot of these things. We are just going to be able to personalize medicine at home.
Yeah. I love that. And so and AI is changing so much in many fields. And astrobiology is certainly a realm of human studies where there's a lot of applications of machine learning and artificial intelligence for automation of our spacecraft. Isatu Sar had another question for how you see AI playing a role in interpreting like vast spectral databases of pigments and how that might apply to things like using future telescopes. Do you see AI changing how databases are built, how they're interpreted and looked through for looking for life out there?
Definitely. So one of the features of biopigments is that they have a lot of different signatures in just one spectra. It's very limiting to have just a human eye looking at them, in my opinion. I think actually a lot of the data I'm producing, it will be for AI. It's not going to be for not the human to try to see where a peak is and trying to overlap it. It's very limiting doing it like that. You need a more powerful tool, a tool that actually sees patterns and try to find patterns in ways that we are not going to find it, and try to simulate and try to predict patterns based on previous information. So I think a lot not only is going to be needed, but I think we are actually creating a lot that is appropriate for the way AI works.
Yeah, it's incredible. I actually have to wonder too, like, will AI be able to help us predict other possible pigments and other possible molecules that don't exist yet that could actually help us figure out what those spectra might look like? There's certainly a lot to wonder in that realm.
I think it could be possible if we do more biodiversity work that is translated to astronomy. If we are able to give more astronomers more of the biodiversity knowledge we have and will have, and to close this 70-year gap that exists between the state of art of astronomy and biology. There's still this 70-year gap. And the more we close it, the more data is given to astronomy, and the more AI is going to be able to do its work.
Yeah, that's very cool. I'm going to merge two of our questions that came in from our audience here. Miriam Nassim, who is one of our production assistants, wanted to know currently with AstroCup what the next steps are for your team in this study and actually making this become an option for people who menstruate in space and space settlement. Theophilus Eshfin also wanted to know if hormone suppression would be needed on Mars, and if gravity would have anything to do with that. I'd like to just merge these questions together of where AstroCup is right now and kind of what you see the future being for having these options available.
Yeah, so AstroCup is heading in two directions. First, we would like to test other medical devices because our mission is give options, not just focus in one option. So we are working with other menstrual devices, but also prototypes of menstrual devices that people are developing for Earth that could be already, transported to space in a way, very fast. And then the other thing is we are working with analog astronauts. They are trying them in analog locations as well and giving us feedback on it. And cool. Merging that with the second question, again, I have very, very small memory, which was...
basically, Theophilus was basically asking if hormone suppression would be needed on Mars.
I think yes. And I think the other options as well. So I don't believe we should cut hormone suppression. Just to make this very clear, we should give it as an option for astronauts that wouldn't like to have the menstruation and be bothered by it. We just have to give the other options as well. And I don't think microgravity will have a big problem. I think microgravity microgravity obviously has a problem in fluids. It does not have a problem in menstruation, because menstruation still occurs if you don't have gravity. There's some, peristaltic movements in your uterus and all that. I don't have to go into it, but it does. That's why if you're lying in bed, you still menstruate. A lot of women in the audience will tell you that's true. But it's not going to be because of microgravity. It will be because of giving options for ethics and for sociology and psychology and justice in a way.
Yeah. Epic. If I can just have one more question here before we let you go.
Sure.
This has been so incredible. It's so fun just to hear about your work and your research. Isatu Sar, who had some incredible questions, primarily focused on your microbiology and planetary science research, had two last questions I'm going to bring together. One is if there were specific microbial pigments like bacteriorhodopsin or chlorophyll derivatives that would be most detectable from deep space with future telescopes. And then they also wanted to know if like atmospheric compositions on exoplanets would alter visibility. I guess, their questions together kind of basically are like, what is the best pigment kind of target for us to look for?
That's a great question. And the answer is context, context, context. You know how in real estate is location, location, location? For biosignatures is context, context, context. So I can give you now a very featureful biopigment, but if you have the wrong type of atmosphere, you're not going to see anything. So it's all about how everything combined together. But I can tell you that without an exception so far in my studies, carotenoids are very, very observable, and bacterial chlorophylls are very, very observable, even with an Earth-like atmosphere, for instance. So on an early Earth scenario, they can be good targets. And that is just based on the studies we've published so far. And I think what we're going to see more, and I think AI is going to help, is how all these combinations could give you the best possibilities. And that will help us find targets for our future missions, because we cannot look at everything. Hub Worlds, the Habitable Worlds Observatory, for instance, is going to target just 25 Earths. So choosing the right biosignatures and the right planets will be very important. And it's all going to be about the context and what are the best options that when everything is aligned, there are going to, what are the best options we can pick.
Yeah, absolutely. Lígia, this has been a fantastic conversation. I've had so much fun. I hope people will go out and look you up online and find your awesome website and read more about your research on spectral reflectance databases and things like that and all the cool stuff you've been doing. And I just have to say thank you so much for joining us for Ask an Astrobiologist.
Thank you. Thank you so much for having me. This was really fun. And I've been watching all the other people coming and giving these having these conversations with you. So now it was great to be the one on this side as well, and a great honor, obviously. So thank you.
Yeah, thank you so much. And so for everyone out there who's watching, we're so glad you tuned in for the show. To our audience who asked questions we couldn't get to, I apologize. I always try my best to get to as many as we can, but I'm also a bit selfish, and I love talking to our guests so much and just hearing all the awesome things they're doing. For those who want to stay on the loop on upcoming events, opportunities, and things like that from NASA Astrobiology, or to follow our show and find out about future episodes, you can join our mailing list for the NASA Astrobiology program. Also, I highly recommend you get out there and check out the AstroCup team, a bunch of remarkable people working together to give future women who are menstruating in space and on the moon and Mars and beyond options. And as Lígia showed with us, it's about having options that's most important. So to all of you out there, thank you for joining us. To Lígia, thank you so much for joining us. To all of you, thanks for tuning in. And until next time, stay curious.